is A5. This is for our student that couldn't make it to class. Today we'll introduce the average rate of change, the instantaneous rate of change, how to find that slope on the graph. So graphically, when you're finding the average rate of change, it's just finding the slope of what line? Secant line, yes, touching the graph at 2 points. So you're using f of b minus f of a divided by change of x. If I want to find the rate of change at exactly this point, point A, I will have to estimate by bringing this nearby point closer. All right, when I draw the point passing these 2 points, the line passing these 2 points, the secant line will eventually become tangent line. So you are really looking for slope of tangent at that point. And we actually spent like a couple days trying to find the limit algebraically of this type of function expression. If you find a nearby point, say Q, I'm exaggerating, but the x coordinate is a plus h, right? This is a plus h. Substitute a plus h into f, so y is f of a plus h. Now change of y become f of a plus h minus f of a. Divided by what's the change of x? H. Because we want the gap to be very close, so we find the limit when h approaches to 0. Everybody understand this? Okay? And this part is called difference quotient, right? Difference of y over difference of x. And then you divide, therefore quotient. When you find the limit, you found the slope of tangent line. Okay, this is the slope of a tangent line that you're looking for at that point. So I want to show you this curve here. Can you look at this? I have a function and I have a point. Let's say this is a f of a, 1, 2. Yeah? If I want to find the slope of secant between 1 and 2, right? 1, 2, and then 2, 4. That will be the slope of secant line, right? I use 4 minus 2 divided by 2 minus 1, so the slope is 2. But if I want to find the slope at this point, when x equal to 1, you see this, a plus k, my a is 1 now. So if I make the k, right now k is 1. I need to bring in that point, right? Are you looking? Now the point, the line, is like a secant line. But I cannot make the 2-point overlap. When k is 0, there is no denominator. So you have to have just a little bit. We could make it 0.000001, so that's why when h goes to 0. Alright, and today we are going to find the slope of tangent by using the different quotient. Take the limit. So when you find the slope of tangent, right, let's say it's it's m of t, and you have the point a f of a, just in general. Right now I have 1, 2, but you might have another point you want to find, right? How do you find the line equation, tangent line equation? algebra 1. How do you find the line equation? What do you need? I need the slope, which you found it. What else do I need? A point. That is the point of contact, which I have. So write the line equation. Before, you like to use the y equals to mx plus b, right? But I prefer the point slope form. Y minus y1 is equal to slope x minus x1. Why is this good? Because it have the last calculation. Right now my point is at 1, 2, right? So your x1 is 1, your y1 is 2. And the slope, okay, what is the slope? I need to calculate the slope. Well, I need to find it. Once you find the slope, it's going to be y minus 2. Well, find the slope of tangent and then x minus 1. You can keep it in this form, or you like to move things around to find the slope-intercept form. It's up to you. Okay? So. And what else I want to show you? Right. So, take that off. I'm going to move my A. So can you see right now I have slope of tangent, yeah? I'm gonna go from the left. Is the slope positive or negative? Is the slope positive or negative? Negative. Negative right here, right? It's pretty steep. And then when I move to the right, you see the slope gradually flatten out. Oh, what happened? What happened when I reach this point? Right here. What is the slope? 0. 0. So negative slope. This is slope is 0, right? We also call this horizontal tangent. Because it looks like horizontal. And then after that, look at the slope. Become positive. So this is a positive slope. I'm looking at slope. And it's gradually, what's happening here? Slope is 0 again, right? That's when slope is 0. And then slope is going to be negative, but again, do you notice that there are 2 times for this graph where you have the slope equal to 0? And where is that location? Justin, say it.
Austin.
Austin, sorry. Austin. Yeah. Where does it happen when the slope of tangent is actually 0?
At the minimum and the maximum slope.
Yeah, it's at the top of the mountain, at the maximum and minimum point. That's very interesting, isn't it? Okay? So, good. Just want to show you that. Let's go back. I still have a lot to cover. All right, move on. This is a recap. Can you fill in the blank here? If I want to find the average rate of change between point A and point B, here is A of A. This is B F of B. Can you write it down in terms of A, B, F of A, F of B? Yeah? It should be this. Slope or secant. If I want to find the slope of tangent at A, slope of tangent, right, is the instantaneous rate of change. What would that be? Well, you're going to have a point nearby point right here is a plus h, f of a plus h. And we are going to find the change in y over change in x. So this will be slope of tangent using different quotient, right? It will not be slope of tangent if you didn't use the limit when h approaches to 0. Okay, next step is to find the equation of the tangent line. What is the line of tangent here? You have the slope, this is the slope, is found. And point of contact is a, f of a. Okay, we're gonna use the point slope form. Equation of tangent line is y minus f of a, right? The y value is equal to slope of tangent here, after you find that, substitute that in, x minus a. Done. Is the concept okay? Okay, let's move on. Oh yeah, same thing. Next, now let's use this example. My function f of x is a quadratic, x squared minus 3. Can you find the equation of tangent as the line equation to this curve at x equals to 1? Again, find any line equation, I need the slope. In this case, is slope of tangent. Using different quotient, right, at the limit, then you can find it. So slope of tangent. Now your a value is actually, we say at 1. So instead of a plus h, it will be 1 plus h, wouldn't it? So you're going to find f of 1 plus h, a nearby point near 1, minus f of 1 divided by h. And you're looking for a limit when h approaches 0. We give you the function right here. So I'm going to substitute 1 plus h into x. So basically expand this, right? Substitute that into the function. So this is f of 1 plus h. Do you see that? Minus f of 1. Let's find f of 1. F of 1 is 1 squared minus 3, which is negative 2. So point of contact right here, point of contact is 1, negative 2. Right? You have the point on the line. I just need to find the limit. Then I have the slope. So let's do this quickly. And you have all the tools to find the limit, as we spend a long time teach you the strategy how to find the limit, right? In this case, I cannot sub in h directly because denominator is 0, so I will expand 1 squared plus 2h plus h minus 3. Double negative is 2 divided by h. And notice all these numbers are gone. Oh, h squared, sorry, right here. So 2h over h is 2. H squared divided by h is this. If you write this on the test, I'm going to dock you on the notation for half mark. Do you know why? Right here. What's wrong with this? parentheses because I'm taking the limit for both of the terms. Have the parentheses. Now, you see I have the limit all the way here because I haven't substituted h equal to 0 yet. Alright, so I'm keeping my limit. Now I'm ready to substitute 0, so it's 2. 2 plus 0 is 2. I just found my slope of tangent is 2. Okay? I have the point. I have the slope. I will have the line equation. Ready? Y minus negative 2 plus 2 is equal to, this is the slope of 2. Slope. Yeah? X minus 1. I'm quite happy that you keep the line equation like this. It's okay. Or some people just really a big fan of the slope-intercept form. If you want to simplify, I'm happy to. So that's 2x minus 4. They are both the same equation. How's that? Not too bad. So now I can give you all different kind of function for you to use different quotient to find the limit at a point. I worry about the time, so I'm gonna skip this. This is similar to this one. Yeah? Skip that. I'll put it on my notes. Next one, I'm going to ask you to pair up, go to the board, and then work on these. So find the tangent slope at any point on the curve. What does that mean? So I can keep it in terms of x or in terms of a. So remember our different quotient? You're going to use this limit when x approach to, h approaches 0 of, let's say any point is x equals to a. Okay, let's pretend that's a. So it's f of a plus h minus f of a divided by h. In other words, when you find it, you're going to have a expression in terms of a. Okay? So I'm going to pair you up. I'm going to use this. So I want to show you your pair. Today I'm going to have a, okay, let's pause a little. We are back. So we just have different group work at different function equation to really try to find the slope of tangent equation. So when we say x equals to a, we make a could be anything. So you are using different quotient and then try to simplify and try to find the limit, use all the strategies that you can. Some are using multiply the conjugate right here. And then simplify. So here, when we find the slope of tangent, in terms of a is 3a squared. If function is 1 over x, it's going to be negative 1 over a squared. So now if I say I want to find the slope of tangent at x equals to 1, you just substitute that in, right? Or x equals to 2. A is 2, negative 1/4. So this one, these three groups provide beautiful work. That's great. So slope of tangent, after you simplify, the limit is 1 over 2 square root of a minus 3. Okay? these two are a little more challenging because you have like so many terms. You have to expand more, carefully. And this just is more involved. We can do that later. But ideal is once you find this, I can ask you so many questions. I can ask you to find, okay, for example, I can say, okay, can you find the equation of the tangent line when x equals to 1? Right? So since you already find the slope is 1 over a squared, so the slope of tangent will be -1, and your point will be 1, 1. So the tangent line will be y minus 1 is equal to negative x minus 1. Or I can say, can you find where are the points when the slope of tangent is equal to, say, 1/4. How would I do it? I need to find the location where the slope of tangent is 1/4. As you can see, when I move from left to right, the function, the slope changes. Sometimes it's negative, 0, positive. So when will that be positive 1/4? In this case, you will set up one-fourth is equal to this. And solve for A. This is actually never gonna happen, right? 1/4 cannot, this is positive, so it can never happen. So I give you that example. Maybe negative 1/4 is better. So I will set up negative 1/4 is 1 over a squared. So a squared is 4. What is A?
Negative positive 2.
Plus or minus 2. That is the x coordinate. I say points. That means I need to find the y coordinate as well. But since I have the function, I can find y coordinate, right? When a is 2, 1/2. Negative 2, negative 1/2. At this 2 point, the slope of tangent will be positive 1/4. Okay, question like that. Move on. Last slide is to find the equation of a tangent line. And here I want to introduce another line. It's called equation of a normal line. And the definition of the normal line, okay, I sketch it here. See the orange? Orange is a normal line at A. How is that correspond to the tangent line? What does it look like? They are perpendicular. So line of tangent at A is this green line, right? Line of normal at A is a line perpendicular to the tangent at A. Not just perpendicular to the tangent, because I have so many lines perpendicular to the tangent. All these lines are perpendicular to the tangent, right? Which line is the line of normal at that point? Only this one, because I need to pass through the same point. Are you with me? So, in order to find the equation of the normal line, we also need to find the slope and the point. But since we only have this point, I need to find the slope of tangent first, using different quotient, which you just all did, right? You did your pro finding the slope of tangent. Stand and just say, normal line is perpendicular to the tangent. If m of t is slope of tangent, what is slope of normal?
Negative reciprocal.
Negative reciprocal, because that's what the, perpendicular line relationship. If the slope of tangent is 2, then slope of the normal will be negative 1/2. Like that. That's the one example. Okay? We also need a point on the normal line. Luckily, that's the same point of contact. A, f of A, no change. The only change is the slope. So now how do you put together the line equation? Y minus the same point, right? F of A is equal to, now this is the slope. Negative 1 over slope of tangent x minus A. If you can find slope of tangent, you can find slope of normal. You can find the equation of normal as well. Okey-doke. Let's try this question. Wait. This is a quadratic, right? The question says, find the slope of tangent at x equal to negative 3 for f of x. So can you find the equation of normal as well? Alright, first up, we need to find slope of tangent using different quotient. Because this is what's the point of contact, x equal to negative 3. So I'm going to use f of negative 3 plus h minus f of negative 3 divided by h. Are you okay with this? Same thing, right? Let's simplify this. Substitute negative 3 plus h into x. Into x. What is the function? Something squared plus 2 times is something, we already changed that to negative 3 plus h. Subtract, right? F of negative 3. 9 minus, what is this? 6 over h. Okay, let's take some work to, sorry, this is not x, this is h. I wrote it wrong. Expand. 9 minus 6h plus h squared. Expand here. Minus 6 plus 2h minus 3. Let's see what we can cancel. 9 minus 6 minus 3, that's canceled, right? I'm going to combine this like term. So what's left here? Is negative 6 plus 2, that's negative 4. Divided by h, that's negative 4. H squared divided by h is h. Now I can substitute that in. So that will be, this is 0. So it's negative 4. I just found myself the slope of tangent at x equals to negative 3. You know? So here, slope of tangent is negative 4. So what is slope of normal then? 1 over 4. Yes. Point of contact is this point. Let's evaluate. Substitute negative 3 into it. Got 9 minus 6. So negative 3 is your point of contact. Slope is 1/4. What is the normal line? Y minus 3 is equal to 1/4 x minus -3. There you go. That's it. This is equation of the normal line at x equals to -3, right? Are we good? So let's look at what other questions we can encounter. So here it says that f of x equals to x cubed. The back group, we already find the slope, right, at any given point, didn't we? So slope of tangent, after you simplify that, I'm gonna copy that. 3a squared, after you simplify, okay? We already do the work ahead of time. Now, B, can you say, where does the slope equals to 3? Find all the points, satisfy that. Slope of tangent is not specific. When is slope of tangent equals to 3? Well, this is the slope of tangent. So we are going to set 3a squared is equal to 3. We'll solve for a. Does it make sense? When the slope is equal to 3. Is that equal to each other? A squared is 1. So what is a? 1 or -1, right? Plus or minus 1 is the square. Where means I want to find the point, location. So when a is 1, I need to find the point, which is f of 1. Right? So it's 1, 1, 1. And -1. -1 f of -1. So where is that happening? -1, -1.
Wait, is it just How did you come up with 3a squared equals to 3 again?
This one?
Yeah, and also the top.
This one? Okay, this one you have to expand and simplify. You guys, you did the square root, so you didn't really go through this process. The other group, they did that, so you have to go through, expand the sum of cube, cancel, h, sub in to find that. Okay?
Oh, so that's just like
So
the
that
last
is
few
the
steps.
kind of the slope function. I can sub in a equals to any value to find what is the slope at that particular point. When x equals to 1, slope is 3. When x equals to 2, well, 2 squared, slope is 12, like that. All right, the next page. This is give you a viewpoint of what this means. Right, remember when I move from left to right, the slope changes, right? Very steep slope when you come up from the bottom. And it flattens out. At this point, slope is actually 0, horizontal tangent. And it becomes positive again. But this is not so steep. It becomes steeper as you move to the right. And at what point will you have the slope equals to 3? See, these are both positive slope. These are parallel lines. Do you notice that? And this point we found is -1, -1. That's exactly when you have the slope of 3. Yeah? And when you move to this side, this is actually parallel to this line. Slope is 3. Slope is 3. And this is 1, 1. Yeah? Okay, just one more slide here. This is rational function where this group already found it. See? Show the beautiful work here. So you go through simplifying the function within it. Rational function within rational function. And at the end, we found that at x equals to a, the slope of tangent is actually -1 over a squared. Okay. I will show the full note of how to find the limit. But now, look at the second question. Where the slope equals to negative 1/4. Same thing, right? You're gonna set this equals to negative 1/4 and solve for A. What is A? Also minus 2. So find the point. 2. Negative 2. Yes. Okay. Sorry, can I borrow 10 seconds? This, I just want to say, when we say find the point where F has a horizontal tangent, what is the slope of tangent when you have a horizontal tangent? 0. So, same thing. Set the slope equal to 0 and find the point. Okay. See you next time.